Hello, I'm 𝘭𝘭𝘪𝘯 with Lab Synergy, and I want to present to you the P14 rotor mill. The P14 is a impacting and shearing mill that utilizes a blade, a rotor, along with a sieve cassette. The sample is fed in through the top. Maximum sample size or width is about 10 millimeter. Sample is fed in through the top and comes into contact with a high-speed rotor, which is available in a variety of configurations depending upon the type of sample that is actually being milled. The rotor spins at a rate of anywhere between 6,000 to 20,000 RPM, and when the spinning occurs, the sample is impacted against the walls of the rotor and then sheared along the outside of the sieve cassette, and then the sample is processed and collected into a receptacle here. With respect to the P14, the sample itself can be either collected in a closed collection receptacle or for larger quantities be collected into a large bag, so you can get a lot more sample throughput. Some unique features as far as the P14 are concerned is the rotor itself is very easy to remove, as you can see, from the actual motor. Inside of the system itself, there is a large amount of air to allow for the sample to be cooled down during the milling, because with any sort of milling process you always generate some heat. With respect to the P14 itself, it does have a triple ring system to protect dust or any sample from getting into the motor itself, thus keeping for the sample very not much in contact with the unit itself. And as far as the program is concerned, you could program the time in minutes for milling or just the speed. Typically any sample is milled at the highest RPM, which is 20,000, which is unique to the P14 itself as well. Okay, so what we're going to do is we're actually going to run an example sample, and what we have here is a plastic polymer about 2-3 millimeter in width. And some plastics require the grinding with a liquid nitrogen to keep the sample cool. Otherwise, because of the impact and shearing force applied, the sample could potentially melt. So what we'll do is we'll bring the temperature down to the sample to a very cold environment so that we can mill it properly and collect it in the system.